Good morning and good day, ladies and gentlemen. My name is Juergen Großmann and I'm a scientist and team leader at the Fraunhofer Institute for Open Communication Systems, FOKUS, here in Berlin. I would like to invite you to follow my presentation called A Taxonomy to Assess and Tailor Risk-Based Testing in Recent Testing Standards. The talk is part of the general first track of the ESEC FSE 2020. The talk is based on an article that is my colleagues Johannes Viehmann and Schieferdecker, as well as Michael Felderer from the University of Innsbruck and the Blekinge Institute of Technology, Sweden, have been published in IEEE software early this year. It is intended for developers and managers who have to deal with complex testing tasks in software development, and it motivates and explains risk-based testing, our taxonomy on risk-based testing, and their application to compare the requirements coming from standards with the capabilities of existing risk-based testing tools. Let's start with the question, what is risk-based testing? So testers have a kind of natural connection to risk. Yeah, they find bugs that matter, at least this is their task. And based on this, they often have a kind of intuition on how to deal with risk. The risky parts, the more severe parts of an application. However, when the systems become a little bit more complicated, the perception of risk might become difficult. So let's have a look at this simple system. The system consists of a balloon and a needle. And normally you would expect this to have a quite simple risk profile. However, we added a little at this system and you can see there is a low risk profile and a very high risk profile. And if we test, we can find out the following: low risk profile and high risk profile. So the message is, when the systems become much more complicated than the example that I have shown here, the perception of risks and their assessment and their analysis becomes much more complicated and needs to be done in a systematic manner. Risk-based testing addresses product risk in software development and helps software testers to cope with limited testing resources. So message is, test the most severe, the most risky parts first. Risk-based testing applies to risk in software products and as a guiding factor has the potential to, well, at least steer most of the phases of a test process. That is test planning, test design, test implementation, test execution, and test evaluation. And risk-based testing matters. So current testing standards already recommend risk-based testing. Let's have a look at, for example, the ISO IEC IEEE 29119. This is more or less the testing standard. It consists of, I think, 5 documents. And if you look at the part 2, test processes, you find a risk-based methodology to derive a testing strategy within this standard. You can see it on the right hand side. There's this picture that shows the overall process of creating a test plan within 29119, and the activities underlined with this orange color. This is about the risk-based activities within the workflow of the ISO 29119 test plan creation process. First of all, this looks quite simply as a typical risk estimation process. You start with understanding the context where initial risks are identified, and 29119 recommends to have a kind of risk register where you register all the items and artifacts that drive the risks. Then you have a phase on identifying and analyzing the risks. So in this phase you will review the already identified risks from the risk register, and then you identify additional risks that are especially connected to the activities of testing. You do the risk evaluation and the risk assessment, that is, you put values on the risks and distinguish different risk levels. Then you identify potential risk mitigation approaches. This is the next step. And finally, you design your test strategy based on this kind of risk estimation that you have done before. Another example is the ESEC guide EG203251. This is an ESEC document that especially addresses risk-based testing in the area of security testing. This document follows more or less international standards like ISO 31000 for risk assessment and the aforementioned ISO 29119 for the test processes, and it looks at the systematic combination of both in two directions. On the one hand side, it supports risk-based security testing, that is risk assessment aimed to improve the security testing, and on the other hand, test-based risk assessment. These are test activities used to improve the security risk assessment. So you get the results from the security testing and propagate them back to put evidence on your risk assessment. This guide proposes risk-based activities for all of the phases of a test process. So you can see on the picture on the right hand side that these are the connection between security risk assessment and security testing, once between test planning and the security risk assessment, and especially between test design and implementation, and test execution and analysis in summary. Yeah. And last but not least, also from the area of security, I think this is somehow natural, because especially risk assessment plays a bigger role in security and safety relevant applications. So the OWASP Testing Guide, which is a testing guide that is developed by the OWASP community and focuses on the testing of web application, security testing of web application. And in this document also risk assessment is used to drive certain testing activities, like the allocation of testing resources, for example. So you may put more resources in areas where you expect more severe vulnerabilities, the identification and prioritization of testing requirements. Risk assessment is used to identify adequate testing techniques and at least to put the results in context. That is, if you find vulnerabilities, you can weight their severity according to the existing risk analysis. Yeah, and well, also the OWASP testing guide follows itself established risk assessment standards like NIST 830. So, as we have heard, there is standards that are recommending risk-based testing. What we have done is we have developed a taxonomy of risk-based testing for the purpose of just structuring the field of risk-based testing and to be able, well, to have a tool to be able to compare and benchmark requirements, tools, methods, everything that is related to risk-based testing in a more or less systematic manner. And this taxonomy has three top-level categories that are context, risk assessment, and the risk-based testing strategy. So if we look at the context characterizes the overall, well, setup and context of the risk assessment and testing process. It is itself distinguishes between risk drivers, quality properties, and risk items, while the risk driver determine the major assets in the risk assessment process. So they answer the question, what triggers the risk? So it could be the business, safety, security, or compliance. And then we have the quality property. These are the quality objectives that need to be fulfilled to mitigate risks. So this category somehow answers the question which quality properties might help mitigating the risks that we identify. And here we have, well, I think these are standardized quality properties from the ISO, like functional suitability, reliability, usability, etc. And then we have the risk item, which is the item under assessment. So which is the item that is subject to your risk evaluation. So this answers the question, what is analyzed? Could be a functional artifact, well, like a software unit, an architectural artifact, a runtime artifact like a library. So there are different probability, there are different things that could be subject to your evaluation, and this is covered by the risk item. Next we have the risk assessment itself. So this characterizes how the risk is being determined. So here we distinguish between the factor that characterizes the risk. So it could be the risk exposure, which is the interplay between the impact and the probability. Could be a likelihood, or could be just an impact rating. Then we have a characterization of the estimation technique. So there might be some formal methods like well, Bayesian networks or Monte Carlo simulation that allows you to do the risk estimation, and then we say it's more formal, or it's the formal approach. Or it could be based on lists or questionnaire. Then you have a more informal estimation technique. The next characteristic is the scale. So you can have a quantitative numeric scale or a qualitative ordinal scale. So the first is more typical for safety application, the second more in security, because in security it's much more complicated to get to statistical relevant numbers. And last but not least, we have the degree of automation. So the question whether the assessment is done manually or in an automated manner. So for sure there are interdependencies between these characteristics. So you need some formal techniques to provide a more automatic assessment, but this is not directly covered within this taxonomy. And last but not least, we have the risk-based testing strategy. So this is or this answers the question on how risk assessment is applied to testing. So for what it is used, for prioritization of things, for the automation, for selection, for resource planning, etc. And it also answers the question in which phase of a testing process the risk assessment is applied. So it might be applied as risk-based test planning in the planning process, or as risk-based test design and implementation. For example, identifying coverage items that have a certain kind of relevance regarding certain risks, or a risk-based test execution and evaluation. So if you, as I said, try to put certain findings, certain bugs in a context of the risk assessment. Okay, so this was our taxonomy, and now we're going to show how we use this taxonomy. So in this setting, or for this publication, we use the taxonomy as a systematic tool to relate the requirements and recommendations from standards to the capabilities of approaches and tools that implement risk-based testing. And for that purpose, we looked at 4 different tools and approaches. So first of all, the PRISMA approach might be well known to you. This approach has been defined by van Veenendaal, and it's called Product Risk Management, PRISMA. It starts with a systematic identification of software product risks and define different risk levels based on a risk matrix. So you can see the risk matrix on the right hand side of the slide set, and the main purpose is to classify your software items with respect to the different parts of this matrix, and to define different test strategies for all areas of this matrix. Then we have a risk-based test case prioritization using fuzzy expert systems von Hetiachachi et al. This approach is mainly dedicated for requirements-based testing and tries to use fuzzy expert systems to prioritize testing requirements and thus the overall testing process. And then we examined two own developments. One is a risk-based testing strategy in the context of smart testing. This has been developed by Felderer et al. And it's mainly a process conform to ISO 29119 that more or less enhances the existing risks-driven approach that is already defined in ISO 29119 towards a more major process. And we have the Recomat tool. This is a software tool. You can see a screenshot also on the right hand side. A tool that allows you to drive risk-based security testing based on graphical threat scenarios. And these threat scenarios are based on a risk definition language called Chorus, has been developed by Syntef. And this tool makes use of a large number of automation mechanisms to allow developers to automatically assess risk and to derive test cases out of that. What did we do with these tools? So we put them in context with the existing standards and on basis of our taxonomy. So you can see the table on the right hand side. There is this taxonomy on the left side, then it is followed by the tools, and finally you will find the standards, and finally you will find the tools. And what you can see here is now that how you should read this table. So we have these different elements of the taxonomy, and for each of these elements we compared standards to approaches. We used for the standards the following symbols. If we put an X, if there is an explicitly mentioned or recommended part that addresses this taxonomy element, and an O where we could derive, it was not explicitly mentioned, but we could derive this connection. For the tools and methods, we used a double plus for fully support this category, a plus for partially support this category, and a T if there is tool support for that. And we could conclude that at least our taxonomy showed that there is a good coverage of standards by methods and tools already. However, not all areas of risk-based testing are supported, and scalable tool support is missing. So there are open issues there, and one thing is that especially tool support is missing. So Recomat is a tool, but it's not a industrial grade tool. It's a research prototype, and PRISMA and Smart Testing provide lightweight Excel support. So this is also will not really meet the requirement of an industrial application. However, let's summarize the takeaways. So risk-based testing is a powerful technique that helps identifying and testing the relevant parts and properties of a software system. and it allows you to schedule resources to concentrate on relevant risk. Current test standards increasingly recommend risk-based testing. Methods and tools are available, and we have shown that the taxonomy for risk-based testing has proven good means to systematically analyze and represent the requirements in the area of risk-based testing, good support in comparing standards and methods, and what we see is that this approach can be easily extended and applied to additional methods when required, so you can use it with your own tools and methods to somehow benchmark and compare them with respect to requirements from standards. I hope this was interesting, so you can contact me if you are interested in more information either about the tools or the taxonomy, and I wish you a nice conference, and maybe we meet in one of the discussions. Thank you very much.